Hello everyone, in this video I am going to explain nucleophilic addition reaction. In previous videos, electrophilic addition reaction, free radical addition reactions are completed. Addition reaction is mainly three types: electrophilic addition reaction, nucleophilic addition reaction and free radical addition reactions. So third one is nucleophilic addition reaction. So nucleophilic addition reaction is the reaction in which nucleophile involved in rate determination step. In addition reactions, nucleophile involved in rate determination step. Rate determination step, shortly RDS. What is the rate determination step? In a complex reaction, the slowest step is called rate determination step. So the nucleophilic addition reaction is the addition reaction in which nucleophile involved in rate determination step. In addition reaction, nucleophile involved in rate determination step is called as said to be nucleophilic addition reaction. This is said to be nucleophilic addition reaction. Nucleophilic addition reaction. Nucleophilic addition reaction. In general, alkynes, very rarely alkynes, and mostly carbonyl compounds. Very rarely alkynes and mostly carbonyl compounds and their derivatives involve in nucleophilic addition reactions. Nucleophilic addition reactions. Okay, right. So that means nucleophilic addition reaction in alkynes. Nucleophilic addition reactions in alkynes, nucleophilic addition reaction in carbonyl and their derivatives we discuss separately. So in that first one, nucleophilic addition reaction in alkynes. Nucleophilic addition reactions in alkynes. So in that what is first nucleophilic addition reaction in alkynes? What is first? Addition. This is first one. One minute. These reactions takes place, nucleophilic addition reaction of alkyne. These reactions takes place in presence of heavy metals, in presence of heavy metals, in presence of heavy metals like Hg plus 2 salts, or what do you say, lead salts, or Ba plus 2 salts, barium salts. These heavy metal ions are required because these heavy metal ions attract pi electron cloud from the alkynes. Heavy metals attract pi electron cloud of alkynes and pi electron cloud of alkyne and leave alkyne becomes electron deficient. To add nucleophile, the alkyne should become electron deficient, then only nucleophile add. Electron deficient mean electrophile. Okay, so generally whenever carbon triple bond is there, that act as nucleophile, nucleophilic addition doesn't take place. Whenever alkyne, that is a nucleophile, when treated with heavy metals like mercury, lead or barium, these heavy metals pull electron cloud towards them, then that alkyne become electron deficient, electrophile, then nucleophilic addition is possible, which facilitate heavy metals attract pi electron cloud of alkyne and alkyne become electron deficient, which facilitate addition of nucleophile, So we will see two examples for a nucleophilic addition reaction in alkyne. First, take this one. Okay, I am going to give nucleophilic addition reaction in alkyne. I will explain two examples. First one is nucleophilic addition reaction in alkyne. First example is addition of alcohol to alkynes. Addition of alcohol to alkyne. Okay, so this reaction takes place in presence of BF3 Lewis acid and mercury oxide HGO, alcohol molecule added to alkyne to form acetal or ketol. Otherwise ketol. See this one. If we take acetylene, addition of methanol in presence of methanol is alcohol, this is alkyne, acetylene is alkyne. To this alkyne, what I am adding? Alcohol. That is the reaction. Addition of alcohol to alkyne. This reaction takes place in presence of BF3 and HGO. Okay, that is required here, which gives CH3O added to one carbon and hydrogen added to other carbon. Here hydrogen is added, CH2, triple bond become double bond, here CH, okay, and what is added? OCH3. OCH3. Let's see here, addition of alcohol to alkane. In presence of BF3 and HGO, alcohol molecule added to alkyne to form acetal or ketol. In some cases acetal is formed, in some cases ketol is formed. See this one, here I am taking acetylene. Acetylene is what? Alkyne. Acetylene is alkyne, and this is methanol. Methanol is alcohol. That is the reaction. So addition of alcohol to alkyne. Addition of alcohol to alkyne. This reaction takes place in presence of BF3 and HGO. Okay, thus it gives a product. Here what is the nucleophile? CH3OH. Okay, due to presence of lone pair, this acts as nucleophile. This acts as what? Nucleophile. Nucleophile added to one carbon. So here this is first of all, this is also nucleophile. Nucleophile do not add nucleophile. Here the mercury heavy metal that pull electron towards one side, then on the other side this nucleophile is added. Okay, right, take this one. After that what happens? Addition of one more mercury, addition of one more CH3OH molecule, addition of one more CH3OH molecule in presence of mercuric oxide and BF3, in presence of BF3 and HGO. Okay, again add same. What happens? So this one added here, this one added here, H added here, CH3 double bond become single bond, CH, here what? OH3 added, here already OH3 is present, one OH3 is added. This is called what? Acetal. So here hydrogen, so this is what? Acetal. Acetals are the compounds in which this carbon, this primary carbon containing two methoxy groups, two alkoxy groups. So primary carbon containing two alkoxy groups. Okay, acetal. Otherwise, if you take any other alkyne, not acetylene, if you take any other alkyne, here it may be CH3, C2H5, anything, it may be propane, butane, anyone, then what happen? Here I am taking methanol, so this is what? Alkyne, any alkyne, not acetylene, other than acetylene, any alkyne. So this reaction takes place in presence of BF3 and HGO. So here nucleophile attack takes place. Hydrogen addition here. Hydrogen addition takes place here, and what? OCH3 to this carbon, here double bond, it become CH2, and here what? OCH3, like this nucleophilic addition takes place. So after that again addition of one more methanol in presence of BF3 and HGO. Here what? Or H added to this carbon and OCH3 added to this carbon. Here what? OCH3, and this becomes CH3, hydrogen added here. In this one only, in methanol CH3OH. Okay, by taking electron, this is O minus nucleophile, this is H plus. So OCH3 added to this carbon, H added to this carbon. Okay, right. So here OCH3. Two alkyl groups are present similar to like this, CH3, OCH3, two methoxy group, or maybe two any alkoxy groups present on the same carbon. Okay, but this carbon is not primary, this carbon is secondary. This is what? Ketol. Acetal and ketol. If you take acetylene, the product is what? Acetal. If you take any other alkyne, the product is what? Ketol. Thus, this is a nucleophilic addition reaction. Here alcohol is nucleophile, that adds on alkyne. Alkynes are generally what? Nucleophilic in nature, but in presence of what? Heavy metals. In presence of heavy metals, what happen? This pi electron cloud is attracted by them. They become electron deficient electrophile. Then nucleophilic addition takes place. So for these, what are must? Heavy metals like mercury and barium and lead are required here. So these are nucleophilic addition reactions in alkyne, not important, but nucleophilic addition reaction in carbonyl compounds is very, very important. Okay, so first take this one, later I will explain that. Next example, nucleophilic addition reaction in alkynes is, second example, addition of arsenic chloride to alkynes. In presence of AlCl3 or mercuric chloride HgCl2, arsenic chloride added to alkynes, that is what? Especially that alkyne is acetylene. It forms Lewisite gas. So Lewisite gas is more poisonous even than mustard gas. Lewisite gas is approx 4 times poisonous than mustard gas. 4 times poisonous. That means Lewisite gas is more poisonous. Remember that. Okay, how is it formed? When acetylene formula CH triple bond CH, acetylene when treated with arsenic chloride. So arsenic chloride formula AsCl3. So I am writing one chlorine here. So remaining is AsCl2. In presence of mercury chloride or aluminum chloride, this reaction takes place. So chlorine added to one carbon, remaining rest AsCl2 added to another carbon. So here triple bond become double bond, here chlorine is added, and here to this AsCl2. What is its name? So here arsenic chloride. Here this is first carbon, this is second carbon. 2-chlorovinyl. This group is called as 2-chlorovinyl. 2-chlorovinyl dichloroarsine. 2-chlorovinyl dichloroarsine. This is the name of this one. Its common name is what? Lewisite gas. Lewisite gas is what? Poisonous gas. Thus alkynes, very limited reaction. Alkynes undergo nucleophilic addition reaction. Okay, take this one. Next, nucleophilic addition reactions in second, nucleophilic addition reactions in carbonyl compounds. Okay, these are familiar reaction. Whenever we talk about nucleophilic addition reaction, we must remember carbonyl compound. Carbonyl compounds readily undergo nucleophilic addition reactions. Okay, so to undergo addition reaction, double bonds, triple bonds must. Okay, alkynes usually undergo electrophilic addition reaction and free radical addition reaction. Carbonyl compounds also contain double bond. Carbonyl compounds contain double bond where nucleophilic addition reactions takes place. So when we see carbonyl compound mean between carbon and oxygen double bond is there. Okay, sigma bond, pi bond. Okay, this is what sp2 carbon. This is what sp2 carbon. Some what is hybridization? sp2 hybridization. Here due to more electronegativity of oxygen, pi electron shift towards this oxygen, then oxygen become partial negative and carbon become partial positive. Here pi electrons are loosely distributed between carbon and oxygen. First point, oxygen is more electronegative. That's why this pi electron cloud slightly move towards oxygen. That's why oxygen become partial negative and this carbon become partial positive. Therefore, nucleophile attack takes place, nucleophilic addition reaction takes place here. After addition of nucleophile, here already two bonds are there. This oxygen completely takes pi electron. Here some nucleophile is added. Okay, so this reaction is slow. After this one, what happened in the reagent? Each reagent contain nucleophile along with electrophile also. So after addition of nucleophile, what is remains? Electrophile remain. That electrophile addition takes place on oxygen like this. Here what is present? Nucleophile. Thus addition reaction takes place. To carbon one thing is added, nucleophile. To oxygen other is added, that is electrophile. So this is what fast step. And first one is what? Slow step. So we can say why is this one fast? Because these are negative ion, positive ion, ionic reactions are fast. Here this is not ion. This polar molecule, ionic ions, these are not ion. Just this is not complete negative. Just pi electron move towards this oxygen. That is why oxygen become partial negative and carbon become partial positive. That means this is not ion. Non-ionic reactions are slow, ionic reactions are fast. And we also know slow reactions are what? Slow reactions are rate determination step. In rate determination step, what is added? Nucleophile is added. So this is what? Nucleophilic addition reaction. Okay. So if this carbon become more positive, nucleophilic addition reaction become more fast. That means the rate of nucleophilic addition reaction on carbonyl compound favored by the magnitude of positive charge on this carbon. If this carbon is more positive, then nucleophilic addition reaction takes place more effectively. That means reactivity of carbonyl compound depends on the positive charge of carbon in carbonyl compound. The reactivity of carbonyl compounds in nucleophilic addition, depends on the positive charge on the carbonyl carbon atom. So this positive charge increased by what? Electron withdrawing groups. This positive charge increased by electron withdrawing groups. That's why reactivity of carbonyl compounds towards what? Nucleophilic addition reaction directly proportional to, here if minus I groups are there, electron withdrawing groups are there, then this carbon become more positive. If electron withdrawing groups are there, those electron withdrawing groups withdraw electron towards themselves and this carbon become more positive. That's why minus I effect. minus I effect. And inversely proportional to what? The same thing, inversely proportional to what? Plus I effect. Directly proportional to minus I effect and inversely proportional to plus I effect. That's why as electron withdrawing groups increases, reactivity of carbonyl compounds towards nucleophilic addition reaction increases. Okay, see if you see benzaldehyde, and if you see what? If you see formaldehyde, if you see acetaldehyde, which one is more reactive? Reactivity order, reactivity towards nucleophilic addition reaction. So this is benzaldehyde. This group is what? This group is minus I group, electron withdrawing. This is hydrogen is what? Hydrogen is neutral, neither electron withdrawing nor electron donating. This methyl group is what? This methyl group is plus I group, electron donating group. So plus I groups decreases electron. Plus I groups, what do? They push electron towards this carbon. This carbon positive charge decreases because it is pushing electron. Here hydrogen do not push, do not withdraw. Here this is what? It is withdrawing electron towards itself. It is withdrawing electron towards itself like this. So electron movement takes place towards this one. That means this carbon become more positive. Okay. So here phenyl groups are electron withdrawing groups. Remember that one. Phenyl groups are minus I groups. Here minus I group neutral and plus I effect. That's why here what is my statement? Minus I effect increases reactivity of carbonyl compounds towards nucleophilic addition reaction. Thus benzaldehyde is more reactive than formaldehyde is more reactive than acetaldehyde towards nucleophilic addition reaction. Okay. So I hope you understood. Take this one. Right. See these questions. Arrange the following for the reactivity towards nucleophilic addition reactions in the decreasing order. Which one is more reactive? That one you have to arrange first and less reactive later. Okay, between ABC in the question 1, which one is more reactive? So what I am saying, methyl groups are plus I groups. Plus I groups decreases reactivity of carbonyl compounds towards nucleophilic addition reaction. Here neutral, both hydrogens are neutral. Here this is plus I group, plus I effect decreases reactivity. Here 2 plus I effects, so decreases more reactivity. That's why reactivity order, first A more reactive than B more reactive than C, because in C how many plus I groups? 2 plus I groups. Next here, so CH3CHO, 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 CH2CHO. So CH2CHO, CH2CHO, here H, just take H, CH2CHO. So CH2CHO, CH2CHO. What is common in them? CH2CHO, CH2CHO, H, remove H, CH2CHO, CH2CHO. So CHO means carbonyl compound, they undergo nucleophilic addition reaction. So here what is present? What is present here? Here this is chloro is here. Here what? Nitro group is there, and here hydrogen is there. Hydrogen is what? Neutral. Here CH3. So CH3 is which effect? Plus I effect. Hydrogen is what? Hydrogen is neutral. Hydrogen is neutral. Here nitro group is strong minus I. Nitro group is what? Strong minus I. Here chloro is weak minus I. Chloro is weak minus I. Of course, so minus I groups increases what? Reactivity of carbonyl compounds towards nucleophilic addition reaction. Due to presence of strong minus I group, B is more reactive than Next, weak minus I group, second, A. Here plus I group unfavorable, neutral is better than unfavorable, so C. Then last what? D. BACD order. Next, see here in this question, CH3CHO, just to remove hydrogen, what remains there? CH2CHO, CH2CHO, CHO, CCHO. That means same acetaldehyde and derivatives of acetaldehyde. Here only pure acetaldehyde, one electron withdrawing group is there. Here 2 electron withdrawing group, here 3 electron withdrawing group. So 3 minus I effect, 3 minus I effect, 2 minus I effect, only 1 minus I effect, no minus I effect. As minus I groups increases, minus I effect increases, reactivity definitely increases. So D is more reactive than, C is more reactive than, because is asked to write decreasing order. So B, then what? A. This is the order. Next question, C. CH3CO is common in all. What is changing? Here just CH3, CH3CH2, 2 CH3 groups, 3 chlorine groups. Chlorine groups are what? What about chlorine groups? Minus I effect. Minus I effect. These are plus I effect. How many plus I effects? 2 plus I effects. Here this is what? Only 1 plus I effect. Here this methyl group containing no hydrogen. That's why what do you say? Which one is more reactive? Definitely D is more reactive due to presence of minus I groups here. D is more reactive than A more reactive, because here plus I groups are unfavorable. 2 plus I groups, 1 plus I group, no plus I group. Of course methyl group also plus I group. Compared to methyl, ethyl is strong plus I group, isopropyl group strong plus I group. So here only methyl, here ethyl, here isopropyl. Plus I effect increases gradually, reactivity decreases. So that one is more reactive, A than B than C. Hope you understood. Take this one. Next, examples for nucleophilic addition reactions in carbonyl compound. Examples for nucleophilic addition reactions in carbonyl compound. So in that first example is addition of hydrogen cyanide. Addition of hydrogen cyanide. Addition of hydrogen cyanide. Okay, addition of hydrogen cyanide. So 1 minute, there is a sound disturbance. 1 minute. Right, addition of hydrogen cyanide to I am taking acetaldehyde. Example, acetaldehyde. Acetaldehyde is aldehyde carbonyl compound. This is acetaldehyde. Okay, addition of hydrogen cyanide. Addition of hydrogen cyanide. What is this one? Acetaldehyde. Acetaldehyde, and this is what? Hydrogen cyanide. In hydrogen cyanide, cyano group is minus group. Cyano group is what? So H plus Cn minus. Cyano group is what? Nucleophile. Cyano group is what? Nucleophile. And you know, this pi electron move towards carbon, then pi electron move towards oxygen, become negative, and this carbon become positive. Cn minus added here and H plus added to oxygen. Oxygen negative, so H plus is added, carbon positive, so Cn minus is added. What is formed here? So, and more over, we have to remember this is what? sp2 carbon. Sigma, 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 pi. 3 sigma bonds are there, so this is sp2 carbon. Shape is what? Trigonal planar. Trigonal planar means here nucleophilic addition takes place on this acetaldehyde from two sides, because for a plane acetaldehyde molecule has a planar shape. Nucleophile addition takes place to the plane on both the sides. That means 50-50%. Above side 50%, addition of Cn minus to carbonyl carbon below side 50%. That is 50-50 rhythmic mixture is formed here. Here this become what? CH3. Here this is CH3 and what? OH. This become OH here, and here what is present? Hydrogen. Here Cn is added. This is chiral carbon or not? Yes, chiral carbon, optical active. This is chiral carbon or not? Yes, chiral carbon. Chiral carbon. What is the name of that product? Cyanohydrin. On the same carbon, cyano group and hydroxy group is present. That's why this is its name is acetaldehyde cyanohydrin. Acetaldehyde cyanohydrin is formed here. This acetaldehyde cyanohydrin is due to presence of chiral carbon, that star. This is optically active. Rhythmic mixture is formed here. What is symbol here? Plus or minus in the bracket mean rhythmic mixture. How will rhythmic mixture is formed? To the planar carbon, cyanide nucleophilic addition takes place. This is planar carbon. So from the both sides, on the plane addition always gives a mixture of 2. If that leads to chiral carbon, that is rhythmic mixture. If it is not chiral, there is no question of course, addition from 2 sides takes place, but there is no question of rhythmic mixture. We talk about rhythmic mixture. Rhythmic mixture means dextro-levo mixture. Dextro-levo are optical isomer. Optical isomerism is assigned to chiral carbon only. That's why if this is chiral carbon, we talk about rhythmic mixture. So why rhythmic mixture is formed here? Here addition of hydrogen cyanide, that especially nucleophilic addition takes place on carbonyl carbon from the 2 sides. Since it is planar carbon, sp2 carbon planar, to the plane there are 2 sides. Equal probability is there for the addition of cyanide on that trigonal planar carbon. That's why rhythmic mixture is formed. So if here CH3 is present, I do not talk about rhythmic mixture, because CH3, this is not chiral. Not chiral means not optical active. If it is not optical active, there is no rhythmic mixture. So here all are different. That's why, so whenever chiral carbon appear, we have to think about optical isomerism. Okay, that is my point. Okay, so if it is CH3, C double bond O CH3, I do not talk about this rhythmic mixture. Okay, right, this cyanohydrin. From this cyanohydrin, we get 3 types of products. From cyanohydrin, we get 3 types of products. 3 types of products. Okay, right. If it is partial hydrolysis takes place in presence of base. What? Partial hydrolysis. Or otherwise complete hydrolysis, 2 molecules of water, complete hydrolysis in presence of acid. This is what? Complete hydrolysis. Complete hydrolysis. Or otherwise, if you treat it with sodium borohydride or lithium aluminum hydride, reducing agents. Sodium borohydride, lithium aluminum hydride are reducing agents. That's why reduction takes place. Addition of hydrogen takes place. Here addition of one water molecule, oxygen added to carbon and 2 hydrogen added to this nitrogen. So what is the product there? CH3 OH. Here this become CONH2, and this is H. How many carbons are there? 1, 2, 3. 3 carbons. 1, 2, 3. Definitely this carbon is first carbon. I am giving IUPAC nomenclature also. See, this one first carbon, this one second carbon, this one third carbon. What is the name? 2-hydroxy. On second position hydroxy. 2-hydroxy. How many carbons? 3 carbon. Prop. Those 3 carbon single bond AN. CONH2 functional group is there, amide. 2-hydroxypropanamide. 2-hydroxypropanamide is formed there. Okay, so this is also called as lactamide, lactic acid derivative, lactamide. Lactamide is formed. On partial hydrolysis of acetaldehyde cyanohydrin, lactamide is formed. On complete hydrolysis, again add OH here, H here, OH here, H here. So NH3 eliminated, this become OH. Okay, right. Then what happens? CH3, this is same, and here OH, that is also same. Here hydrogen, that is also same. The CONH2 upon addition of water molecule, OH here, H here, this becomes COOH. And ammonia also formed here. What is formed here? Ammonia. One more addition of one water molecule, CONH2, addition of one more water molecule, second water molecule, CONH2 become COOH and NH3. So this is what first carbon, second carbon, third carbon, 3 carbon atoms are there, 1, 2, 3, 2-hydroxypropanoic acid. 3 carbon atoms are there. So this is what 3-hydroxypropanoic acid. 3-hydroxypropanoic acid. You know, 3-hydroxypropanoic acid is also called as lactic acid. 3-hydroxypropanoic acid is also called as, 2-hydroxy. On second carbon OH group is there. 2-hydroxypropanoic acid is also called as lactic acid. Common name for it is lactic acid. So, or otherwise, only hydrogens are added here. Only hydrogens are added here. So, it becomes CH2, it becomes NH2. Then what it gives? CH3 same, and here OH is same, here hydrogen is also same, but this becomes CH2 and this becomes NH2. What is this one? Propylamine, 2-hydroxypropylamine. What is the IUPAC name? 2-hydroxypropylamine. 2-hydroxypropylamine or propanamine. 2-hydroxypropanamine. Both names are correct. Propanamine or propylamine. Propanamine, 2-hydroxypropanamine is formed here. So this is what one example for nucleophilic addition reaction in carbonyl compound. Just I have taken example hydrogen cyanide addition on acetaldehyde. This is important example. Cyanohydrins are formed. That cyanohydrin has importance, which has partial hydrolysis. If it undergo partial hydrolysis, it form lactamide. If it undergo complete hydrolysis, it form lactic acid. If it is reduced, it form 2-hydroxypropanamine. Okay. So next example, addition of sodium hydrogen sulfate. So take this one, or otherwise I will continue in next video. There are some more examples. This video will become lengthy, so I will give in next video. This video closed here. Take this one.